I've made lots of progress on the machine since I last uploaded the video. I've been a bit too busy actually working on it and with other stuff to actually edit the footage together that I've got. So at the moment the machine is essentially complete. I've connected all the axes together, and my next step will be to actually tune it up and attach the spindle. But following is the process I went through to get where I am now. Since my last video, I've connected this Z-axis onto the Y-axis here. So I modified the motor mount that I designed earlier on in this blog. This is the modified motor mount. The only difference between this and the normal one being these holes for M8 rod to pass through beneath the part. These little 90-degree connectors that I talked about in blog number 8 have obviously allowed me to connect these two reinforcements at whichever angle was necessary to connect to these pieces which run along the base. This is integrated into the I guess you would call this the X carriage, which is running on the X-axis, and the Z-axis is bolted. There are bolts coming up through the base of the X carriage into the Y-axis. This is the X-axis carriage. It has 3 full layers glued together and 1 partial layer beneath where it will support the Z-axis. These pieces connect to the threaded rod which connects to the top of the Z-axis as reinforcement. These consist of 3 layers as well, so there'll actually be 2 in the completed carriage. And these threaded rods are just providing more reinforcement, because once the spindle is in here, it's obviously going to be extremely heavy. But I'm happy with the result. There's hardly any play in the angle of the Z-axis at all. So the X and Z axes are assembled now, and they're actually moving, and I found out that I didn't actually need to use the counterweight. The Z stepper is actually powerful enough, at least via the threaded rod system, to move this entire heavy spindle motor up and down on its own. Because what I had intended to do is attach a similar carriage to this one on the back here, which would have carried maybe a bottle of water or something like that of a similar weight to the spindle, which would have assisted the motor. There wasn't actually any need for that in the end at all. The whole reinforcement structure is very rigid. I'm happy with all of that. The only problem being that there's actually some play in the V-wheels, between the V-wheels and the C-beam, which is definitely going to be amplified along the length of this, and obviously affect the position of the router bit. And the reason for that is that the holes, the mounting holes for the V-wheels, I don't know exactly why, I copied the position for the mounting holes for the V-wheels off a drawing on the Open Builds website for the plate that should be compatible with the C-beam. However, when the eccentric spacers here, when they're pointing with the largest portion towards the C-beam, the wheel only just touched the C-beam. So obviously that meant that there's no possibility to adjust it to have any further tension, and it wasn't actually quite close enough to the C-beam to hold it securely even. I thought that was kind of strange. It may be a slight sub-millimeter inaccuracy on my laser cutter, I'm not sure, but to solve that problem I had to now cut new plates, I'm going to actually have to replace the entire back plate of this and the entire lower plate here of the Z carriage as well, which is a bit irritating, but again, I'm kind of motivated by the fact that I've proven that at least the motors are strong enough. The system is basically sound. I just needed to move these holes and these holes 1/4 millimeter in each, so there's like 1/2 millimeter less width here. That should introduce some kind of range of adjustment on the eccentric spacer, which is going to go in there. I've also changed the shape of this hole here, which is, for instance, on the old style carriages, this is where the nut trap would fit in, and it fits incredibly tightly. There's no play at all within that hole, which is great, but the problem is that as soon as you adjust the eccentric spacers, what would be the centre line on this plate is no longer the centre line, and it is just slightly pushing the threaded rod off centre and bending the whole thing, or at least it would be if I managed to tighten these wheels up sufficiently. So my new design of nut trap is far more solid, and it includes these bolts going through it, and the idea is that the bolts will tighten onto these slots here, which will give it a latitudinal movement which it didn't have before, so I can just adjust it to fit exactly the position of the threaded rod which is passing through here, once all of these wheels have been adjusted, and tighten these on, and it should actually be more solid than it was before as well, because it was always difficult to try to fit this through an incredibly tight hole here. I'm just testing the new Z spindle clamp plate here before I cut any more out of acrylic. I've literally moved each hole 1/4 millimeter closer to the centre, and that made had a noticeable effect when I tightened up the eccentric spacers. There doesn't seem to be any play in this at all now, at least none that I can detect by just pushing it. I may find that changes when I put the spindle on there, but I think this is the best that I'm going to achieve in acrylic anyway. I've just finished cutting out what should be the final piece of the puzzle, as it were. This is going to be the Y-axis carriage. This is obviously only the first layer. This is the design for one Y-axis carriage. There'd actually be 3 layers in the completed part. This is the bottom layer with the thinner channels just for the bolts that connect the nut trap on. This is the top layer. There will be 2 top layers, just with slightly larger channels for the bolt heads that connect to the nut trap, and there'll be 2 of these. One of them on this end of the Z-axis, and one of them on the other, and this actually has holes in it, 5mm holes, so that I'll be able to attach T-nuts into the base of this V-slot and tighten it on. It's got 7 V-wheels on the bottom, and obviously that means that in total the X-axis is going to be riding on 14 V-wheels. So I've just bolted these drop-in V-nuts, well, that is T-nuts, onto this piece here, so I can then slide it onto the C-beam base. So this is just temporarily tightened on. I'm obviously going to have to countersink these holes here because it's going to be very close to the C-beam which is running that way. You can see the drop-in T-nuts are in there. Very solid fit. Even though there's going to be 3 more layers, I feel like this itself is actually pretty solid. You have to imagine this there is going to be on here. Another one of these pieces on that side, and the whole thing is going to run on parallel C-beams, which will be the y-axis. I've been searching for springs to fit these last two anti-backlash nut traps for the parallel y-axes. I usually try to buy stuff on eBay to the exact spec that I need, but as I probably mentioned before, I've had trouble finding springs which are the exact dimensions that I need. There are these sort of sellers who will just chop up sort of lengths of spring to the length that you want, but the problem is a lot of them don't seem to actually kind of terminate the spring correctly so that it will have a flat surface which will engage properly at the back here. They just kind of have a totally unfinished length of spring. But I was just looking in my local pound shop, and I found these pruning shears endorsed by TV personality Charlie Dimmock. Maybe it's not very good news for her that something that's branded by her has ended up in the pound shop, but I reckon that this spring here should probably have just about the right internal diameter to fit onto an M8 rod. And as I noticed when it was in the pack, it's obviously compressed to roughly the right size, so I just figured I can take that out and give it a go on a bit of I don't actually have the right sort of steel rod to finish these off, but I can at least give the spring a go to see if it's the right sort. So I haven't really shown how these new nut traps that I've made work, but what I tend to do is put the threaded rod into it about that far, so it would just about meet the nut where I'm trying to attach it. Put in the spring. I'm not sure, maybe it's actually expanding a bit too much, this spring, to like within the hole to be useful, but I'm just going to give it a go. At least the hole is definitely, the gap in the internal diameter of the spring is big enough for M8 rod, just as long as it doesn't kind of wobble around too much in there. Yeah. So that was rather more difficult to get on than the other springs that I've been using, because it's so much longer when it's extended. But the most important thing is how it behaves when it's actually in place. I can't actually feel it springing at all. So I'm just going to try cutting this in half. I know I was moaning about unterminated springs just now, and I'm about to create two of them when I cut this into... if I can cut this in half. So in the end I had to use a pair of bolt cutters to cut the spring in half. The other half of this one is inside that nut trap at the moment, and it's certainly, well, obviously it's reduced the tension by half. That is the compression that's keeping these two nuts apart, and which is pressing on this layer of the nut trap here. It's moving very easily, but as the threaded rod is spinning very easily. It seems like the tension is pretty, that is, the compression is still pretty good, but I'll really only know whether it's adequate when I actually use the machine. So at the moment I'm installing the two y-axis carriages onto the bottom of the x-axis. So this one is going to fit there, and then I need to insert the C-beams onto these before I can place the whole machine back upright again. I've had a bit of trouble with the bottoms, with the bottom of this piece and the bottom of that piece. I've had to do quite a lot of filing to make this flush so that this piece can fit on there. So I think in the next version of these parts I'm going to reduce the kind of width of this part coming down that way, because there's no real need for it to meet the bottom of this even. I'm using this engineer's square to initially try to set the y-axis at a right angle to the x-axis. I feel like I'm likely going to have to do a bit more adjustment later on, but this will do for a start, I think. The reason I'm using this as well is just to try to get the y-axis the right distance apart. What I realised I should have done is actually marked the distance this should come to onto this part here, with maybe just with a laser cut line or something like that, because it's basically I'm having to line it up approximately, and then when I attach everything to the baseboard here, I'm maybe going to have to drill the holes to fit the position of the y-axis rather than the other way around, or I may just need to readjust. The other problem with this is that you can only adjust the y-axis carriages without the C-beam installed, so that could actually make setting this machine up initially quite difficult. Okay, now I'm about to fit the right hand C-beam onto the right hand Y carriage here. I've been quite nervous about this step because once the motor is installed, these are very heavy, these are very tight, and this is just resting on the top of my laser cutter. So I think there's a lot of potential things that can go wrong, but it seems like the weight, when I put this carriage on, it seems like the weight of the motor actually helped me fit it onto the C-beam. So here goes. I mean, you need to keep the C-beam wheels, that is, you need to keep the V wheels tightened up almost as far as they will go, so it's good that this is tight. It just makes assembling the machine quite difficult. I just need to screw the other end plates onto the C-beam here, and then this will be ready to set back upwards, and we'll see maybe about synchronizing the two motors here, so I can then connect it to the base plate. I'm going to home each y-axis, that is each half of the y-axis separately. I connected the y-axis end stops here. You can see both of them are open. I just tested the minimum one to make sure that that's plugged into the correct socket, because that's the one that's going to be used to home the y-axis. I had to plug the max y end stop in as well though, because otherwise the axis won't move. I've just done basically a million tests to make sure that everything's in order, and I'm now going to home this part of the y-axis. So that's definitely going in the right direction. That's definitely the correct end stop. So let's see how this goes. I think I'll probably be able to tune the router up to run a bit quicker than this. But apart from anything else, I don't want to overload the driver chips while I don't have any cooling attached. I've got heat sinks on here, but I want to put a fan on before I start running the motors at maximum speed. Okay, it should start to... Yeah, there you go. I had my finger on the power supply switch, but it's successfully homed that one. I just need to do this one now. This is the same procedure again, except with the end stop here connected and this motor connected. I'm just going to press the Y home button. And then once these are both lined up, that will be a good time to connect them down to the base, which is going to carry the whole thing, which is actually lying here at the moment. I very carefully lifted the machine over onto this workbench now. Clearly it's too high to actually run it properly on the workbench, although I could probably get about 10 centimeters of movement backwards and forwards. It's kind of taking a benchtop CNC machine a little bit far, I suppose. I mean, having said that, once I reduce the height of this axis a little bit, it would be more of a sort of compact machine. But I want to keep all the pieces of C-beam whole for now, because this is kind of like an intermediate machine. As I've probably mentioned before on this blog, I intend to use this to make an aluminium machine. That is, to make a machine using aluminium sheet as all the kind of fixtures on it instead of acrylic. So until I have my final machine, I don't really want to cut down the C-beam at all. But my thoughts are probably that this will end up being 30 centimeters instead of 50 at the most. But of course I want to keep it whole for now, because I don't know whether I want a machine which is capable of a more 3D cutting. This is now optimized for two-dimensional cuts, because that's what I need to make on it. I need to cut out of sheet in a two-dimensional style. But obviously if you have a longer Z-axis, it means that this could potentially become a 3D printer as well as a router, because it would be useful to kind of condense all the functions of my different CNC machines into one machine. So for instance, attach a laser, attach a 3D printing head, and have the capability of routing all on the same machine. But the next step is to glue together these two sheets that my friend Savas cut out for me, which are 50 by 50, and obviously the C-beam itself is 50 centimeters long. Then I need to make a fairly neat row of holes through here, so I can bolt up into T-nuts on the C-beam. So this is going to be the base. This is going to fit like that, obviously underneath this frame. I was trying desperately to keep these two pieces of wood as flat as possible as I was gluing them, and as the glue was drying, but as you'll see in the next segment of the video, this whole thing was quite pointless, and I don't advise doing this like this. I let the glue dry for 24 hours, and now I'm going to use the technique I saw in one of Savas Papasava's videos. I'm going to use a torch and an engineer's straight edge to assess just how flat this surface is. If it's not flat enough, potentially I'm going to have to brace it with studding, that is wooden studding or aluminium or bars or something like that on the underneath. So it's a good idea to measure diagonally and parallel to each edge and the other diagonal. That's actually looking pretty good. I think that this that line there is actually just glare in the camera. I don't see any light shining underneath that at all. And maybe a little here. So the other diagonal, not so hot. So probably if I place, not bad. It's a little bit there. Okay, this edge seems like the worst because it's not totally flat. I was going to try to brace it with this because this is like the fastest thing known to man, the straightest thing that is. But I realised that because it's glued together, it's actually going to make it harder to flatten this out than if it was a single sheet of 18mm ply. So I tried to separate it with these, and it's just a total mess. I really screwed up, but I suspect that I found something else which is actually flatter than anything I could have made myself, which is this piece of reclaimed workshop from a discount DIY store, and unfortunately they don't sell any old worktops anymore. I think they realise how valuable they actually are, but I'm going to use the straight edge on this and see if I can just use this is the base of my machine instead. Really solid, really heavy, and despite having been outdoors in a wood storage shed for a while, it looks pretty flat to me. I did the same test with the straight edge and the torch, and I found out that the edges weren't particularly flat, but kind of the central place where the moisture hadn't penetrated was very good, so I just cut out a 50cm square from the centre of that piece. I just stuck this clip in here to show you that I do have some practical skills. I don't just design on the computer all the time. What you don't see here are the long pauses between each cut where I made sure that all the edges were going to be as parallel and square as possible. I'm scoring lines 1cm and 7cm in from this edge and from that edge, and those are for bolt holes to attach to the C-beam. It helps to have a dark surface to mark into actually. Those lines will serve as a guide when I cut the holes on the drill press. The harder a process is, the harder it is to film, and I didn't actually film myself attaching the C-beam to the worktop, but you can see here there are bolts running up through the holes that I drilled along those two parallel lines that I scratched into the surface of the worktop. These are flat head rather than countersunk, to give the C-beam a bit of lateral play so that I could adjust it so that it's exactly parallel. So I wasn't relying on those two lines to be perfect. There's always going to be some adjustment involved to get the C-beam perfectly aligned with its partner on the other side of the board. Obviously it's important for the two y-axis C-beams to be parallel when they're bolted down to the base. I got this one as square as possible with the edge of the base, and then I only bolted down one end of this and left this other end free to move. I told the machine to move the y-axis all the way to this end, so obviously that maintained the distance between these two beams, and then I could bolt down that end of that C-beam. So that's one thing. I attached the C-beam on, but before that I attached these rubber feet. I just screwed them into each corner of the board. That's it's obviously neater to do that because there's all these bolt heads protruding from the bottom of the board, but apart from anything else, it will make it easier to isolate it acoustically from whatever surface it's on, so that hopefully it won't make a massive noise. It will still be very loud, but it won't be nearly as bad as if the bass was sitting directly on the work surface. What I've been considering eventually is putting acoustic isolators like these, which are on my rep wrap, underneath the CNC router. So this is the machine in its current state. It's obviously too large to use on the desk where it is at the moment, so I need to move it down to the workshop before I carry on. I have done a bit of testing moving the axes around. Before I attach the router, I actually need to write a program to create the correct G-code for this. My next steps will be to actually tune up this machine to make the x-axis exactly 90 degrees to the two y-axes. I'll probably have to pick one of the y-axes to refer off. All I'll need to do is get a set square and then move one of these motors independently of the other to bring the x-axis exactly in line with the set square. But that's for another week. Once I finally complete this project, I'll upload a full set of the final designs in SketchUp, and I'll link to them in the description of this video, and whichever the final video is on my channel. So please do like, subscribe if you haven't already, and maybe go off and laser cut or route out your own copy of my CNC machine. If you're wondering what these last two clips are, this is what I did when I discovered that the base of my machine wasn't flat. And as you can see, I have no sense of health and safety whatsoever.